Welcome. This is a video series that is expected to provide assistance to the small, medium, and self-employed sector entities. Today, I am going to discuss the relationship between present value and future value with compound interest. Present value and future value is widely used in investment appraisal of projects evaluation, and intend to use the interest, I should say the compound interest formula, which was fully explained in my last presentation, and I am going to derive two formulas as to how the present value and the future value to be calculated from the formula that is going to derive. And I take this opportunity to provide another information to small, medium, and self-employed sector businesses. If anyone is carrying out such business, there is a manual that is published by the Sri Lankan government to those people and those who wish to commence new business. This publication provides immense information to those who intend to start the business. So if anyone interested, they can respond to my email address, or they can send a request to my email address appearing on the slide 1, so that I can provide them with the PDF copy of the same manual to such requests. Thank you. We'll go to the next slide. As you see, the present value formula to be derived from the compound interest formula. You can see the compound interest formula. Compound interest formula, as you see, A equal P within brackets 1 plus R into the power N. So if you need to represent the formula in terms of P, you can divide the same formula both sides by 1 plus R into the power N. So as you see, when you divide both sides by 1 plus R into the power N, you will see the right side, the 1 plus R N will cancel off to this one 1 plus R N in the up of the formula. Then you will have only P on the right side, and on the left side you have A divided by 1 plus R into the power N. So finally you will get P equal A divided by 1 plus R into the power N. So that we have expressed the formula, the same compounding interest formula in terms of P. So what we do here, instead of P, right, we replace the P by PV, and instead of A, we have written FV. Okay, so PV represent the present value, FV represent future value. So if we rewrite the formula based on the new notation, the new formula, or rather the repeating of the old formula will be written as PV equal FV divided by 1 plus R into the power n. So that is how we divide the present value. PV represents present value. That is how we derive the present value formula. So from the present value formula, when you come up here to right side, I have written the present value formula, and by cross multiplication, you can see I have indicate this to express the cross multiplication. Then on this you will have FV into 1. So FV into 1, again FV, and on the other side PV into 1 plus R into the power n. Then that is we can express as PV into, within brackets, 1 plus R into the power n. So here again we have expressed the same formula in terms of FV. So FV represents future value. So let's go to the next slide. So here I have given a sum which is based on compound interest formula. The sum indicate that B deposit rupees 10,000 into bank account on 1/1/2023 at compound interest of 20%. So the question is asked, what is the total interest to be received at the end of third year, and the total amount to be received for the same period. So manually I have calculated here first year, second year, third year, and at the end of third year you will have 7,280. The manual calculation is very simple. You apply 20% rate on the initial amount of 10,000, and the interest is 2,000, and from the beginning of second year you will have to apply 20% on the 12,000, because the interest portion also gets added into the initial amount. So we will end up with 2,400. And again third year the amount is 14,400 into 20%. So it will get added to 7,280, plus if you want to see the full amount, we will have to add back the initial 10,000. Then you will end up with 17,280. So where we have indicated the initial amount equal to P. P means the principal. R, the simple R equal rate of interest, here 20%. N represent time, and A the total amount. So let's see how the same answer to be derived by using the formula. Let's go to the next slide. So I have given the two formulas that we have derived from the compound interest formula. So let's first calculate the future value of this example. Here the amount that we are going to invest today is 10,000. So 10,000 is written here. 1 plus R represent 1 plus interest. So 1 plus interest is 21.20%. So how you get 20.20 is 20 divided by 100. So into the power, how many years? 3. So when you multiply 1.20 into the power 3 into 10,000, you will end up with 17,280, the same amount that we have got. And same way, if we apply the amount that is there in the example, we can calculate the present value also. Here the FV represents 17,280 future value, right? Then it is to be divided by 1.20 into the power 3. Then when you divide 17,280 by 1.20 into the power 3, again we will end up with 10,000. So the present value of 17,280 is 10,000. So we will get the same amount. So then you will understand how the formula works. And at this moment, I wish to explain another concept that is also based on this present value formula. Now, here the present value formula, we are going to calculate the present value of rupees 1. Say in your country, it is not rupees, it may be dollar, or it may be any other currency, right? So if you apply the present value of 1, right, then you will be arriving at different figures. So in year 0, assume that you are in year 0, that is right now in year 0, that is right now represent year 0. Year 0, 1 is equal only 1. So no depreciation. Rupees 1 equal 1. Right? Then when you go into year 1, that is 1 year after, then what will happen? When you divide the 1 by 1.20 into the power 1, you will get something lesser than 1. That is 0.8333. How? Because the rupee depreciates. So likewise, you will have year 2, year 3 calculations. So year 2, 0.6944. Year 3, 0.5787. So this is what you call present value discounting factors. So this is how you calculate present value discounting factors. Okay, thank you.